all the videos need to be recorded. Okay, so look, commutative law means what? That if you interchange the input, your output is unaffected. This is what? A or B. Or even if you take like this, so this is what? This is the same thing. So OR operation is what? It is commutative. Now similarly you can check for AND also. Okay, you can check for NAND, NOR also, XOR and XNOR also. Okay, so this is what I meant by commutative law, that if you interchange the input, your output remains unaffected. Now the next is what? So this might be asked, okay, this might be asked in your option based question, that which of the gates follow commutative law or which of the gates are commutative. So you need to write all the gates are commutative. Now what if I ask you what is associative law? So what do we mean by associative law? What do I mean by associative law? So associative law, what we mean, that if I take preference, okay, suppose if I have three inputs, so here I won't be drawing the diagram. If I OR three inputs in this order, so if I interchange the order, is the expression same? Yes, it is same. So you can see OR gate is associative. Similarly, let us check for AND. If I interchange, basically what? If I interchange the operations, or if I basically interchange the order in which the inputs are getting your, means I can say what? That they are basically getting operated on. So if it remains same, so I will say associative law is hold true. Okay, so this is what? This is your AND. Even AND is following associative. Now let me ask you if NAND follows associative law or not. What is happening? Okay, so my screen, this mobile screen, it got black. So let me ask you, is your XOR gate, does it follows associative law? Quickly tell me. Does it follows associative law? See, these type of questions will be asked. Okay, theory based questions. So this is HAL exam. In GATE exam you won't be getting such kind of question, but in your HAL exam you will be getting lot of theoretical question. So XOR gate, if you check, this is also associative. XNOR gate, if you see, so this will be also associative. What about NAND and NOR gate? NAND and NOR gate. What about NAND gate, NOR gate? What do you think? So NAND gate, if you see, okay, look very carefully. is this equal to, is this equal? Is this equal? No. Very good. It is not equal. Okay, this is not equal. So NAND and NOR gate, they don't follow associative law. Okay, so this is important. This is important. Once in NTPC interview, this was asked suddenly, okay, by the interviewer, that which Boolean gates are associative. Okay, so it was asked to me in my interview that what is associative law and which of the gates are not associative. So you need to be very quick. You need to answer NAND and NOR gates. They are not associative. Okay. So now there are lot of actually properties. Wait a minute. Okay. So the first property is what? Distributive property. So this you might be even knowing, and even if we don't know, you will be able to solve questions. It's no big deal. So the first property is what? A plus BC. I can expand it and write A plus B, A plus C. Okay, this I can write. This I can write as AB plus AC. Okay, this I can write. So such kind of properties basically we require to solve question. So one of the question I have given to you, this is one Boolean expression. I want you to minimize it or tell me what will be the minimized expression. Okay. So first question, let me ask you, is this Boolean expression minimized? If not, then minimize it. So very quickly do it. So tell me. Just give me a minute. Yeah, I'm really very sorry. So yes, it's not minimized. It will be A plus B bar C. Very good. Very good, Sankari. So look here. This expression, it is not minimized. Okay. It is not minimized. Why? Because I can minimize it. Look how. ABC plus AB complement C. Now take these two terms and this two. So you will be seeing what? If I take AB common, so this will be 1 plus C. And if I take B complement C common, 1 plus A. Now, according to Boolean algebra, we should be knowing that 1 plus a, this is always equal to 1. 1 into a, this is equal to a. 0 plus a, this is equal to a. 0 into a, this is equal to 0. Now, a is a Boolean function. So, a can take value either 0 or 1. It doesn't matter. Whatever is the value, these are your Boolean identities. Okay. Now, look. A plus a complement, this is equal to 1. A into a complement, so this will be equal to 0. So these are few Boolean identities that I wrote for you. Now look over here. I can write it as AB plus B complement C. So this was not minimized. If I had to write the minimized expression, it will be AB plus B complement C. Now let me ask you, what is this known as? What is this whole expression, or this minimized expression, and this, what is this known as? This is known as your consensus law. Okay, consensus law. Now based on this, let me ask you one more question. Yes. Tell me, what will be the minimized expression for this one? So look here. Okay, look here. I will tell you the shortcut. So whenever such kind of expression is given, it is cyclic in nature. Cyclic means what? There will be always term of AB, BC and CA, or I can write AC. Okay, you can see. Now check for the variable which has a complemented form and a non-complemented form. Okay, check for the variable which has a complemented and non-complemented form. Okay, so over here you can see A, both of the variable, wherever it is written in both the terms, it is A complement. Check for B, B is also in its complement form. But look at C. C is present in complemented as well as in non-complemented form. So retain the terms of that variable which has complement and non-complemented form. So B complement C plus A complement C complement will be retained. Now go and look back to the previous example. So here you can see B has both the complemented and non-complemented. Others like A has only non-complemented, C has also non-complemented. So retain the terms of B because it has both the complemented and non-complemented form. Okay, is this clear? So this is very simple. Now one more kind of expression in consensus law, it might be asked like this. Okay, so again for this one, this is written in what? Means you can see this is in POS form. So we will see what is POS form, what is SOP form. In the next slide only we are going to see. So this is written in POS or product of some form. Product, you can see these are product and these are your sum terms. Okay. So if you see, only C is in complemented and non-complemented form. So retain the terms of C. So this will be B plus C, A plus C complement. Okay, A plus C complement. Okay, so now let us talk about dual of a function. So what do we mean by dual of a function? What do we mean by dual of a function? See, by dual of a function, we mean basically wherever in a function we see 0, we replace it with 1, and whenever we see a 1 in a function, we replace it with a 0. Okay? And whenever we see and, we replace it with or, and we replace or with and. So look, how do we find basically the dual of this function? So this is your Boolean expression. So if I want to find dual of this expression, so simply what I am going to do, look in between, if nothing is here, so that means these are all and. So convert this to plus, this will be C plus D, this will be E plus F. Okay, so this is your dual of the function. Now if your Boolean expression, so this is very important, if Boolean expression is true, then its dual expression will also be true. Okay, its dual expression will also be true. So what do I mean by this? So 1 plus a is equal to what? I said this is 1. So if this is the function, if I take dual of this, so this will be what? 1 will be replaced by 0, plus will be replaced with a dot. So you can see this was a valid Boolean statement or a law, Boolean law you can say. When I took dual of this, so you can see I am getting a valid expression. So whenever you have a valid function or a valid Boolean expression, the dual of that function, it will be also valid. Okay, is this clear? Any doubts in this? So now let me ask you, what will be dual of this? So what will be dual of this? Very quickly find out. See, so what I am going to do, I told you, replace dot with plus and plus with dot. So that means what? This will be a plus b into, means in, not into dot, and this will be what? I should be not putting this bracket, c plus d. Okay, so this will be the dual of this function. Okay, dual of this function. Now let me show you how to calculate the complement using dual of a function. Okay, how to calculate your complement using dual. So we know what? Example, this is what? And we know what? Complement of this, it is what? AB plus A complement B complement. Now assume if this function, this is the function given to me, I want to find the complement of this function. We know that the complement will be x nor, but using help of dual, I am going to show how to calculate complement. So first, in calculating complement, first step is calculate the dual of the function for which you need to find complement. So if I take dual, so this will be what? A plus B complement, and this will be dot, plus will be replaced with a dot. Okay. Next step is what? Complement each of the terms separately. Okay, complement each of the terms separately. Okay, so if I complement, so this will be what? So if you solve this, this will be what? A complement plus B, and this will be A. Okay, so here there will be a complement, sorry, A plus B complement. So solve this, A complement into A. Now open this, so A complement into A plus A complement B complement plus AB plus B complement into B. So we will be getting A complement B complement plus AB. So you can see I am getting the result that we know. Okay, so we are getting the result that we know. With that, I want you to find the complement of this function, this complex looking function, very quickly. Very quickly find complement of this. So look, if you have found out the complement, look here. So the first step is what? Calculate the dual. So if I calculate dual, take care of the brackets, okay? So here it is A. This plus will convert to dot. This will be B complement plus C. Over here, once again, I have dot. So this will be plus D into, or open bracket, into E plus F, and this will be G. Simply I have replaced all the plus with dot and all the dot with plus. Okay, so this is the dual of this function. Second step is what? Take complement term by term of each of the dual function. Okay, each of the variable you need to take what? You need to take complement. So if I take complement, A complement dot B plus C complement plus D complement dot E complement plus F complement dot G complement. So here I had one complement. Okay, so this will be complement complement. Okay, so yes, this is okay. Even here also, since I forgot to write all the complements. Okay, yeah, now this is okay. So next step will be what? A complement dot B plus C complement plus D dot E complement plus F dot G complement. Okay, yes. So is this clear? This is how you find the complement for a function, or simple, even you can do this also using De Morgan's rule. Also you can expand it, but that will be a little bit more time taking compared to this method. So directly you could have done what? You can take whole complement and then you can expand it using what? De Morgan's rule. You can even do that. Okay, no issues in that also. Now the next is, how many unique Boolean function, or before this, let me directly ask you this question only. This question. I am giving you like 1 minute to think about it, and then we are going to solve. See, you cannot take, and this is your PSU kind of question only. Put the formula, get the result. B. Okay. So this is good. Good. B is the correct answer. Okay. B is the correct answer. So option B is correct. Now you might be wondering why. So I will give you a very simple example. Suppose you have a single variable. Okay, single variable A. With the help of this, how many functions can you make? So first function will be like this. Second can be like this. Third can be like this. Or fourth function can be this. So with the help of a single variable, you can make 4. Now if you have A and B, how many such functions can you make? So the answer will not be that simple. You cannot tell me that, sir, it will be 2 to the power n, or this will be 2 to the power 2. So this is 16. Directly you cannot say. Okay, if you have memorized, then it's okay, but if you don't know, how will you then do? So look very carefully. I will just give you a basic hint. Okay, basic hint, and then you are going to solve it later. See, in Boolean expression, A, B can take values like okay, it can take values like this. So what I am assuming, that the generalized function, it looks like this. Okay, alpha A complement B complement, beta A complement B, gamma AB complement, delta AB, where this alpha, beta, gamma, delta, they are basically binary numbers. So how many combinations of alpha, beta, gamma, delta can I have? How many such combinations can I have? I will be having, because these alpha and beta, it can be 0, 1. This beta can be 0, 1. This gamma can be 0, 1. And this delta can be 0, 1. See, in the last example also, I have done this only. See, here what I would have written, I would have written it like this. F is equal to alpha into A plus beta into A complement. So then alpha could have values, means alpha beta could have been like this: 0, 1, sorry, 0, 0, 0, 1, 1, 0, and 1, 1. For 0, 0, this function will be 0. Okay, so 0 you will be getting from here. For alpha equal to 0, beta equal to 1, this will be what? A complement. From here, sorry, so this will be A, and for this one it will be A plus A complement. So you will be getting this one. Okay, this you will be getting. So like this, you can have any number of, means only 4 number of functions over here. So here, how many such combinations you can have? Because alpha, beta, gamma, delta, they are your binary numbers, so you can have 16 such combinations. Okay, from 0, 0, 0, 0 to 1, 1, 1, 1. So there are in total 16 combinations. So for a 2 variables, you will have 16. So if you put in that formula, so it will be 2 to the power n. Okay, so for 3 variables, it will be 2 into 2 to the power 3. So this will be 2 to the power 8 or 256. So this is a one generalized formula. Okay, now the next representation. Okay, before going, let me ask you a few questions. So tell me, what will be the answer of this question very quickly? Answer of this question. And yes, Surjit, you had asked me for measurement notes. Okay, so I will send you the notes. Okay, I will send you the notes. Means I also don't have short notes. Okay, basically my notes are also gate notes. I haven't prepared short notes for measurement. Okay, so I will try to send you some material. A. Okay, so this is what AB plus A complement C plus BC is equal to AB plus A complement C. So this is your consensus law. Okay, so they have asked what will be the dual form. So the dual form will be A plus B, A complement plus C plus, sorry, dot B plus C is equal to A plus B, A complement plus C. So which option do we see? A plus B, A complement C. Option A. Now one thing to note is that whenever in such kind of questions, okay, whenever it is in such kind, means this kind of question, take proper care to scrutinize the options. Okay, because sometimes here you can see that it is not, means look at option A and option C. If you see the left hand side, both of them are same. So if you just go by checking the left hand side and if you mark option C, then that answer will be wrong. Okay, answer will be wrong. So always scrutinize the options very carefully and then mark your answer. Okay, in HAL or any PSU exam, the options are very confusing. Okay, very confusing.
Sir, 1 second, sir.
Yes.
Uh, could you please explain that 2 raised to n case, that second case, a little bit more?
Which one? This one. This one.
Yes.
See. Basically your alpha, beta, okay. So these are the combinations of alpha, beta that I can make. So look very carefully. When alpha, beta, gamma, delta are all zeros, your function will come out to be 0. Okay, function will come out to be 0. Now look at this case, alpha, beta, gamma, delta. So out of that, alpha, beta, gamma, they are all 0, only delta is 1. So delta is the coefficient of AB. So here your function will be what? It will be AB. Look over here, here this delta is 1. So that means this function will be A, B complement. Over here you can see what? That gamma is 1, delta is 1. So if you look at this two, it will come out to be A. Okay, if you take, so this will be what? AB complement plus AB. So you take A common, so that you will be getting a. Similarly, you can solve for all the functions. So here it is, how many functions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you will be getting different kind of 16 Boolean functions. Now is it clear? Is this clear?
Okay, sir. Okay.
Yeah. So the next question, let me ask you is this. What do you understand by this? And then I will be explaining. Just a minute. Let me see what else we have in this. Okay, so KMap and prime implicants and essential prime implicants. So that is a very important topic. So in HAL for electronics, I guess there is no measurement. Are you appearing from electrical, Surjit? EC. Questions won't be asked that much. Okay, I will mark the important topics for you and I will try to send some materials to you also. Okay. Okay. You can pay a little bit more attention in your sensors and transducer part. Okay. Rather than studying a measurement, I will say sensors and transducer part, it will be means little bit more questions might be asked, because aeronautical division, anything in HAL or BARC, usually sensors are more prominently used. Okay, so that is why I am telling you. So what answer are we getting over here? Means what happened? See, so look very carefully. Okay, so you guys know what is this? What these are? What do we mean by this? This sigma m 45678, sigma m 1615. Okay, it's okay. If you don't know, it's okay. Do you guys know? So what is this? Min terms. Others? All of you know that these are min terms. Okay, it's okay. It's okay. Later on, we will solve this question. First, let me tell you what is min term, max term, and then we are going to see. Okay. So now we have what? We have representation of Boolean expression. Okay. So the first that we have, the first kind of representation, it is what? Sum of product representation. Now, what do we mean by this sum of product representation? So look very carefully. If I have a Boolean expression which is function of a, b, c, that means it has three variables. And if I take a random Boolean expression like ab plus ab complement plus ac complement plus ab complement c complement. So such kind of expression is known as what? Sum of product. So look over here, sum of product, sum of product. So these are all product terms. Okay, these are all product terms and individually they are summed. So that is why it is known as sum of product. Okay, sum of product. So this is a normal SOP. Okay, normal SOP. Now there is something known as standardized SOP. Now what do we mean by standardized SOP? So in SOP, basically all these product terms, they are known as your min terms. Okay, they are known as your min terms. Now in standardized SOP, all the individual min terms should contain your all the three variables a, b, c, because the function is defined for your three variables. So all the min terms should have your all the three variables. So how do I make a standardized SOP? So look very carefully. If I want to convert this into standardized SOP, so this will be a, here b is present, c is not present, so this will be c plus c complement, plus this will be what? A, b is not present, So I can write it like this: C complement plus A B complement C complement. So this will be ABC plus ABC complement plus ABC complement plus ABC B complement C complement, and this is AB complement C complement. So this is what, this is your standardized SOPY, because you can see all the terms of ABC are present in each of the min terms. Okay, in each of the min terms you have all the terms. So this is known as your standardized SOP. Now if I ask you, why is this known as min terms? Or another way of asking, in SOP basically we pay more attention towards 1 than towards 0. If I ask you that, so let me show you one example. So here basically this A, B, C, they are all Boolean variables. Okay. So now for what combination of A, B, C will this be 1? For what combination of A, B, C this will be 1? You will be saying, sir, for A equal to 1, B equal to 0 and C equal to 1, this expression will be 1. Now, if I ask you the same question with a difference, that for what combinations of A, B, C will this expression be 0? What will you say? What will you say? See, this is unique combination. Unique. Other than this combination, you will be never getting the value of this expression as 1. If you don't take A equal to 1, B equal to 0 and C equal to 1, you won't be getting this expression equal to 1 in any other case. But for 0, I won't be having such unique case. I can assume, even I can take like this. So all the combinations of A, B, C, it will be basically 0. So in min terms, your 1 has a very, very important role. Okay, why? Because when we construct SOP, you can see each of the individual min terms, it is equal to 1 for a very unique combination of the variables. Did we understand this concept? Did we understand this concept? This is very important. And one more concept, in your SOP, basically your complemented terms, complemented variables correspond to 0 and non-complemented variable correspond to 1. Okay, non-complemented variables, it corresponds to 1. Now let me show you one very quick example. Suppose if I have A, B, C, so what I had written means, in that question, what do we mean by like sigma M2468? What was it? Okay, so look over here. This is your A, B, C, 3 variable. I have assumed 3 variable. So A, B, C can have values like this. A, B, C can have values like this. The corresponding min terms will be, for this I told you what, 0 corresponds to complement and 1 corresponds to non-complement. So this will be A complement, B complement, C complement. This will be A complement, B complement, C. This will be A complement, B, C complement. This will be A, B, A complement, B, C. This will be A, B complement, C complement. And this will be A, B, C. Now look, these are your binary numbers. The equivalent decimal will be what? This will be 0. This will be 1, 2, 3, 4, 5, 6, 7. So when I write this expression, So this sigma m, this corresponds to SOP. Okay, this corresponds to sum of product or sum. So basically what do we mean by this? We mean sum. Okay, sum of min terms. So suppose if I have something like this 2 4 6 8, if I write this is your function, something like this, so this actually corresponds to that function is what it is. Your means I should have written it like this: function a b c is equal to this. So this corresponds to what? Function is actually a complement b c complement plus a b c plus a b c complement plus a b c. So this is what I mean. So this is a shorthand version of writing this. Okay, so this is what we mean by min terms. Okay, there is also one more way to write this. If I had to write, so I could have written it like m2 plus m4 plus m6 plus m8. I could have written it like this also. Okay, so this will be what? These are your min terms. Now the same concept follows for your product of sum. So look very carefully. If I have a function, a 3 variable function, something like this, okay, so this is what? This is your product of sum, POS form. Why? You can see basically individually they are sum terms, they are added sum, this is also sum, this is also sum, and they are product. So that is why product of the sums. Okay, sum. Now individually they are known as your max term. Okay, max term. But before that, let me show you what is standard POS. Okay, standard POS. So what do we mean by standard POS? Just like we have calculated standard SOP, standard POS should have all the 3 variables in its max terms. So here what I can write? I can write it like f is equal to a plus b plus 0. I can write it like this. So this expression won't be changing. So this 0, I am going to replace it with c dot c complement. Over here b is missing, so I can write it like, and here nothing is missing, so this will be written just the way it is. Okay, so now if I expand this, so we have just now seen the formula that a plus bc is equal to a plus b into a plus c. So here I can assume a plus b as x, so this will be something like this. So I can write it what? X plus c into x plus c complement, where x is what? A plus b. So I can just open it. A plus b plus c, a plus b plus c complement, a plus b plus c, a plus b complement plus c, and last will be what? A complement plus c complement plus b. Okay, okay, so this is your standard POS form. Now in POS you should be knowing that 0 has more priority. Okay, 0 has more priority. Why? So let me show you. Suppose if I take a term, so tell me, for what combination of A, B, C will this expression be 0? You will be saying, sir, if we take A equal to 1, B equal to 1 and C equal to 0, then this term will be 0. Okay, this expression will be 0. Now if I just change the question and ask you, when will this be equal to 1? There is no unique combination. Why? Suppose if I take C equal to 1, B equal to 1, A equal to 1, you will be getting 1. If I take C equal to 1, B equal to 0, A equal to 1, still you will be getting 1. If I take C1, B equal to 0 and A equal to 0, still you will be getting this as 1. So that means what? Whenever we search or whenever we want to make POS, we always look for zeros. Okay, we always look for zeros. Something in chat? Sir, sometimes they don't mention the MSB, then by default always we take the pattern written. Yes, obviously, if they have written like this, F A B C, and they haven't mentioned anything about MSB or LSB, so this is MSB, this is LSB. If it is written like this, then obviously X is MSB, Z is LSB. If it is written like this, obviously P is your MSB, R is your LSB. Even if it is written like this, and if nothing is mentioned, then which one will you take MSB, which one will you take LSB? Surjit? C will be MSB, A will be LSB. If nothing is mentioned, whatever is written in the argument, the first variable will be MSB, the last variable will be LSB. Okay, so keep this thing in mind. So yes, I was saying in POS kind of form, your 0 is always unique. So over here, you will be writing 1 corresponds to your complemented form and 0 corresponds to your non-complemented form. And you can even see over here, see this one corresponds to A complement, this one corresponds to B complement, and 0 corresponded to C. So in POS form, we always search for zeros, and 1 corresponds to complement and 0 corresponds to non-complemented form. Okay, fine. So let me show you one more example over here. Suppose we have again A, B, C. Okay, so now what will be the corresponding max term? So I told you 0 corresponds to what? 0 corresponds to non-complement and 1 corresponds to complement. So this will be A plus B plus C. This will be A plus B plus C complement. This will be what? A plus B complement plus C. This will be A plus B plus C complement. This will be what? A plus, sorry, A complement plus B plus C. This will be A complement plus B plus C complement. This will be A complement plus B complement plus C, and the last term will be A plus B plus C, all having complement. So this corresponds to your capital M0, capital M1, capital M2, capital M3, capital M4, like this till capital M7. So if I write a function something like this, so this pi means product of max term, and if I write something like this 0, 1, 3, so this actually means that Means if over here it was written f x y z, so 0 will be corresponding to what? X plus y plus z. How did I know this, that this will be max term? Because it is written product of max term. So this will be like this. This will be x plus y plus z complement, and 3 will be written as what? It will be written as x plus y complement plus z complement. Okay, so this is what? This is another way of writing the functions. So max term, min term. Any doubts in this, you can ask. If you have any other queries also, you can ask. Okay, or else we will be going to KMap now. Okay, KMap, we will learn about KMap. So now see, this sessions are basically not that much theoretical, so I cannot explain you that much. Okay, I cannot explain you that much, but still we are going to try. So how many of you guys know KMap? So KMap, I hope all of you know. Okay, so KMap basically use gray code. So this is a two variable KMap. So this is 0 1, this is 0 1. So this will 0 0, this cell will correspond to AB equal to 0 0, that means 0 1 2 3. So suppose if I have your function, so KMap is used for what? What is KMap used for? If someone asks you what is KMap used for, so solve this question first. Let me see how many of you can solve. How many of you have some idea about KMaps?
Sir, 1 and 2.
1 and 2, option D. Okay. Okay, chat with everyone. So someone is saying option C, 1 and 3. Okay. So C, someone is saying D, but only one of the options can be correct. So let it be. We will solve this after we know about K-maps. Okay, and then we will see how many of you come to the same answer. Okay. So K-map. So K-map is used for reduction, not reduction. K-map is used for minimization of Boolean expressions. Okay. Suppose if I have expression like AB plus AB complement. Okay. If I have one expression like this. So this is a two variable Boolean expression. So if I want to minimize it, this is not minimized. I can take A common. So this will be B plus B complement. So this will be equal to A. This is very simple to solve. Now if I wanted to solve this using KMap, how will we solve it? So look very carefully. AB means what? This corresponds to 1 1 plus 1 0. So this corresponds to what? M3 plus this corresponds to what? M2. So this is M2 and this is M3. And always remember, whenever you want SOP or whenever you are filling using SOP, the cells need to be filled with 1. Okay, cell needs to be filled with 1. So look here. Now in KMap, basically first thing, few points I'm going to write. We make groups of ones for SOP and group of zeros for POS. First point. Okay. If I want to get SOP expression, I make group of ones. If I want to have POS expression, minimized POS, we make group of zeros. Second point, size of group, it will be always to the power of 2. So 2 to the power 0, 2 to the power 1, 2 to the power 2, like this. So group size will be either 1, 2, 4, 8, 16, like this. Third, no only vertical and horizontal group allowed. Now what do we mean by this? Suppose if I had a KMap, something like this. Okay. So now you might be thinking that you can make a group of 2 like this. Okay, group of 2 ones like this. But this is your slanted group. Only vertical and horizontal groups should be made. So that means what? If I had some combination like this, so one of the group, it will be like this. Another group will be like this. Okay. Fourth point, our main aim for minimizing an expression is to a reduce the, okay, first I shouldn't be writing this, maximize the group size. Okay, you need to maximize the group size, that if you are searching for one, then try to find a group of 2 ones. If you find group of 2 ones, try to search for group of 4 ones. Okay, like this, maximize group size. Second is to minimize number of groups. Okay, minimize number of groups. Okay, so your main aim or whatever theory is required, I have written everything over here. Now let us try to solve this. So you can see I solved this normally. Now if I wanted to solve it using KMap, so I can make a group of 1 like this. Now search for the common variables in the both the cells. So you can see b equal to 0 in this cell, b equal to 1 in this cell. So this is not common. But look over here, a equal to 1 is common in this cell. So I could have written this as a. Why? Because a is equal to 1 and 1 corresponds to non-complemented form. So that is why the function comes out to be a, and this is what we got. Okay, this is what we got. Now one more thing I want to show you. In KMap, if there is no don't care. Now what is this don't care first? First, let me tell you what is the statement. So in a KMap, if there is no don't care, then all the positions that is not occupied by one is what should I write? Is by default occupied. Okay. By default occupied by 0 and vice versa. That means what? See over here. See, I gave you a function that looks something like this. So here you can see these are your vacant position. So what is don't care? I will just now explain. At the moment you assume that there is no don't care. So the places that are not filled by 1, those are the places where zeros are there. Okay. So 0 means what? We search for 0 when we look for POS. So basically these places were empty, these were not filled with 1, so they were filled with 0. So if someone had asked you what will be the POS expression for this, so you could have made a group like this. And what would you have written? So look over here, a is equal to 0 is common in both the zeros. So 0 corresponds to non-complemented form in POS. So this is coming out to be A. Now look very carefully. When I had grouped your SOP or when I had grouped 1, at that time also I am getting A. When I am grouping zeros, at that time also I am getting A. Now, one more thing let me ask you. This SOP or POS, okay? SOP or POS, are they same? SOP and POS, are they representing a same function or different function? Tell me quickly. Are they representing a same function or a different function?
Same function.
Are you sure? Same function or different function? What do you guys think? Okay. So let me answer this by a question. Okay. And after that, we are going to see what is don't care. Suppose this is your 3 variable KMap. So I am not going into that much detail now. Okay. Suppose if I have ones in this position, or this is okay. I have ones in this position. So the remaining positions like this, sorry, I have ones in all the following cells. So the remaining cells, they don't have don't care, as I haven't mentioned anything about don't care. So the remaining cells are what? They are filled with zeros by default. So when we want to write SOP, we look for ones. When we want to write POS, we look for zeros. So first, let me write your SOP. Here I will be grouping ones. So this is one group of 1. This is another group of 1, because there is no other possible grouping that I can do. I cannot even increase the number of group size. Here it is what? Here it is group of 2. Group of 2. I cannot make a group of 4. So if I write the SOP expression for this, so here you can see A equal to 0 is common. So this will give rise to one min term, and that will be what? A complement. And out of B and C, what is common? B equal to 0 is common. So this will be B complement. So this is the min term for this one. For this one, what it will be? No, this is not X nor. This is not X nor. So this will be what? Okay, so
Yes, sir. Yes, sir. It's X.
okay, you have written A X nor B. Okay, okay, fine, fine. Yeah, I saw that it is A X nor B X nor C. Okay, so look. So basically, this is what? This is A. A is common over here, and C equal to means B equal to 1 is also common. So this will be AB. So if I want to write the SOP expression, this will be what? This will be A complement B complement plus AB. Okay, A complement B complement plus AB. Okay, so now let us group the zeros. Okay, so if I group the zeros, once again you can see this will correspond to a max term, and the max term will be what? Here A is equal to 1 is common, so plus means A complement, and out of B and C what is common? So B equal to 0, so plus B. For this one, what is common? A equal to 0 is common, so A plus what is common in B and C? You can see B equal to 1 is common, so B complement. So if I write the POS expression, so that will be A complement plus B, A plus B complement. So if you expand this, this will be what? A complement into A, that will be 0. A complement B complement plus B complement into A, or I can write it as AB, and this will be B into B complement. So you can see we are getting the same result. So SOP and POS, they are representing the same function. Basically what? That is actually a different style of representation. This SOP and POS, it is actually what? A different kind of representation of a same function. Okay? So don't ever get confused. Now, what will be this? What function will you get? If you solve this, this will come out to be A complement B complement, sorry, complement I am telling. A XOR B XOR C. So in examination, lot of times this has been asked. Okay, this has been asked, and they have given options and asked which of the following is the means which of the following expression is this KMap. So you need to write this is A XOR B XOR C. Now if I ask you what will be the KMap for A X nor B X nor C, how will the KMap look? Very quickly answer me. Answer.
Diagonally other way.
Diagonally other way you are telling means something like this. This is what are you trying to say? This?
Actually, yes, sir.
Yeah. So very good. Alternate positions with 1. Very good. And this is the wrong answer because you guys forgot what I told you. with XNOR, we have this property that if there are odd inputs, it is acting as your same as your XOR. If it has even number of inputs, it will be acting as your complement of XOR. So over here, these are what? Odd number of inputs. So whatever is the KMap for XOR, same will be the KMap for XNOR. Did we understand? Tell me yes or no.
Yes, sir. Yes.
So you guys were making a mistake. Now now you people might have understood what is 4 variable KMap also. I am not wasting time anymore. Let me tell you what is don't care. So can anyone tell me what is don't care condition? What is don't care condition? Anyone know what is binary coded digit?
The combination for which output can take either 0 or 1. Actually, that is don't care.
What? Pardon? Once again say.
Sir, for defined combinations of input for which the output can take either 0 or 1, those kind of things are called don't care.
Either it can take 0 or 1. So that means what? What is the specific term for that?
Sir, if one input is given, the other two inputs, even if it is 1 or 0, it doesn't matter. We will get the same output.
See, all of you are partly correct. So there are some functions or some places where actually the combination of input is invalid. Combination of input is invalid. So I have taken one example. Binary coded digit. So in binary coded digit, all the basically, suppose if I want to write 9 in BCD, okay, if I want to write 9 in BCD, so 9 is a decimal number. If I want to write it in BCD form, so I will represent this 9 using its 4-bit equivalent binary number. So that is 1001. If I want to write 10, so I will be writing this 1 using its 4-bit binary equivalent. So that is 001, and this 0 as 0000, and completely if I want to write 10, so that will be 0001 and 0000. Okay. Suppose if I want to write 21, so this in BCD it will be represented as 0010 0001. So this is basically what? 8421 coding. 8421 means this position has weight of 8, 2 to the power 3. This has 2 to the power 2, 2 to the power 1, and this has 2 to the power 0. So this corresponds to BCD 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But using 4-bit binary digit, we can represent number from 0 to 15. So what about, sorry, where did 8 go? So I have skipped 8. So this is 8. This is 9, and next will be 10. Okay. So now if I write 10, this combination is invalid in BCD. Why? Because BCD 10, it is written like this. Okay, this is your binary equivalent of 10, not the BCD equivalent of 10. So that means what? This condition from 10 to 15, it is what? It is invalid. So for invalid conditions, it doesn't matter if I take it as 0 or if I take it as 1. While minimizing the expression, I can assume it to be either 0 or I can assume it to be 1, depending on whether I am minimizing a SOP expression or a POS expression. So if I am minimizing a SOP expression, it will have values 1. If I am minimizing your POS expression, it can take zeros. But okay, later on I am going to tell that. Specifically, we don't consider it as 0 or 1. We consider it as don't care. And we usually use this don't care to increase the size of our groups. Okay, to increase the size of our groups, we use don't care. So did we understand the concept of don't care? What do we mean by don't care? Any doubts? Okay, so the first question we have over here. So don't care are represented as using this symbol or using this phi symbol. So whichever way you can have. So very quickly, tell me what will be the minimized expression over here. So now you will understand what I was trying to say. So very quickly tell me. What option are we telling? A, very good. Okay, let me check. So this means what? A dash, C dash. So basically that means A complement, C complement. Okay. So it is given what? The minimal product of some function described by the KMap given in figure. So what I need POS. So I can make a group of 0 like this, another group of 0 like this. Okay, I can make this two group of 0. So if I solve this, this will be what? You can see over here, C is your, means I can write C is common. So C equal to 1 is common. So this will be what? C complement. And out of AB, what is common over here? So you can see A equal to 0. And for this group, A equal to 1 and B equal to 0. Okay, fine. Now tell me, is this correct or not? And you can see obviously this is not correct because none of the options are matching. Now why did this happen? This is, yes, I will only say. Wait a minute. So this is actually the correct representation, no doubt. Okay, this is this representation for this kind of configuration. It is correct. It is correct. Correct. But it is not minimized. Not minimized properly. Why? During minimization, we can use the don't care for increasing the group size. We can always, now if you think that don't care, sir, you told us don't care can be either 0 or it can be 1. So you are considering zeros over here and making one more group. So this is wrong. Never ever make group of don't care. Don't care is only used to increase the group size. So look very carefully. I have a don't care in this position. So what I can do, I can make one group of 4. So previously it was a group of 2 like this. But if I consider this don't care to increase my group size, how can I group? I can make a group of 4 like this, and one more group of 4 I can make like this. So now if you solve, this will correspond to C equal to 1. So that is C complement. And this one, this is product of sum. Product of sum. So this is first sum term, then product. What about this one? So this you can see A equal to 1. So that is A complement. So which option do we see? Option A. Now suppose if you had wanted to group ones, okay, you wanted to get SOP expression, so you will be grouping one. So this you get using POS. Now if you group using SOP, so you will be grouping ones. So you can see only possible group is this. Now you will not be doing this. I told you either you can consider don't care as 0 or 1, but nobody is going to write this don't care as 1 over here and making one more group like this. This is wrong. You don't individually group don't care. Don't care is only used for increasing the group size. So here only this is possible. So if I write the min term for this, so C equal to 0 means what? C complement. And out of AB, what is common? So A equal to 0 is common. So this is, again, you can see you are getting the same thing using SOP and POS. Okay, so option A is correct. Now next, this one, just now I told you. So you can see this is one direct question. So you will be saying, sir, option C is correct. This is your A complement, B complement, C complement. Okay. Now tell me using means what will you mark the option for this question? Very quickly tell me. See, look here.
D1 and 2.
Okay, D you are telling. So consider the following statement. Minimizing using KMap may not provide unique solution. Okay, it may not provide unique solution. Redundant grouping in KMap may result in non-minimized solution. Don't care states if used in KMap for minimization, the minimal solution is not obtained. So this is wrong. We have just now seen that if we use don't care, we get minimized. Sometimes we get minimized solution, sometimes we don't get. Means if it is used in increasing the group size, then it will give us the minimized solution. Like in the last case, when we were grouping zeros, it was giving what? It was giving the minimized POS. But when we group one, we never required this don't care. Okay, so don't care, if we are able to use it, it will always give us the minimized expression. So option 3 means this statement 3 is wrong. Next is what? Redundant grouping in KMap may result in non-minimized solution. So this means what? Like again in the last case, so not in the last case, I will make one more KMap over here very quickly. So let me make you understand what is this redundant. Suppose if I have a 3 variable KMap, something like this. Okay. So now what I decide to make a group of one like this, another group of one like this, and another group of one like this. Okay. So here I will be having three min terms, one for this one for this one, and one for this one. See, whatever I get, okay, whatever min terms I get, it is correct. Okay, it is correct, but it will not be minimized. Why it will not be minimized? Because you can see I have grouped this group of means this 4 ones in a group of 2, when I can make a group of 4 something like this. So redundant group means what? Extra groupings that I am doing. Basically, that is what is meant by redundant grouping. So redundant grouping in KMap may result in non-minimized solution. So this is correct. First is what? Minimizing using KMap may not provide unique solution. Obviously, it is not going to provide you unique solution. Now it is up to me. It is up to me. Like, suppose now, what do I mean by this? It may not provide unique solution. See, I can group this one like this. I can group it like this. Okay. Okay. So now either look here very carefully. Okay. So I have this. Now either I can group this one with this one. Okay. I can group it like this and this with this. So this is also okay. I can group this one with this one and this with this one. This is also correct. So there is actually what? I might not be getting a unique solution with KMap. Okay. So option 1 is also correct. So D is correct. Okay. D is correct then. Now solve this question very quickly. Solve this question. Solve this question quick. So what is given in the question? The Boolean function can be expressed in canonical, SOP and POS form for the function y is equal to a plus b complement c. Which are the two forms? So they are asking for y is equal to a plus b complement c. Tell us the max term and min term. So this is very, very simple. See, you want to calculate min term over here. Na? So look, I will tell you one shortcut. Okay. So this is one of the min term. Okay. But this is not standardized min term. Standardized SOP, this is not standardized SOP. We can get the min term number using standardized SOP. So here you can see this y is function of a, b, c. Okay. This y is function of a, b, c. So the first term is what? A. So B and C is not present. So I am taking it like this. Now A means what? This I am now writing what? I am writing SOP. I am writing SOP. So normal variable, it corresponds to 1 and these are variables. So either it can take 0, 0 or it will be 0, 1 or it will be 1, 0 or it will be 1, 1. So these may be the combinations for which I might be getting A. So if you solve, this is what? This is your 4, this is 5, this is 6, this is 7. Okay. So these are the min terms corresponding to A. Now similarly, I can write for B complement C. So B complement C means what? A is missing, B complement corresponds to 0 and C complement corresponds to 1. So the combinations possible over here will be either 0, 0, 1 or 1, 0, 1. So this corresponds to what? 1. This corresponds to 5. So the min terms that are present over here is what? It is equal to 1, because 1 is coming from here. 5, it is present in both. So once we are going, means we are going to write in ascending order. So this will be 4, 5, 6, 7. So look, in which option do we have? 1, 4, 5, 6, 7. Option B we have. Any other options? No. So this is your what? This is your min terms. The remaining numbers are what? They are your SOP. So we even don't need to calculate. Okay, we don't even need to calculate the SOP. So simply what you can write, the remaining numbers, that is 0, 3, any other number, 3, 4, 5, 6, 7. So 0 and 3. Okay, even 2 is not present. So 0, 2, 3. So you can see even it is given over here, and we can find out from this also. Any doubts in this? So B you guys are telling, that is good. So option B is correct. Now solve this question. You guys told me that it is C. Someone told it is C. Others also solve. So again, let me solve. So look here, basically this F1, F3, F, these are your min terms, okay? These are your min terms. So whenever, suppose, if I have AND gate, okay? So I have your functions of A, B, C, okay? So F1 is min term numbers. So F1 is the input to this input, okay? So this is 1, 2, let me assume. And F2 is min term number 2, 3, 5. So output will be what? Output will be the common min terms. So you can see 2 is common in both. So output will be like this. Suppose for the same case, if I had OR gate, here you can see min term is what? 1, 2, and here it is min term 2, 3, 5. So for the same case, if I had OR gate, all the min terms will pass, and the common min terms, you will write it only once. So here it will be 1, 2 is common, so write it only once. Remaining are 3, 5. Okay, so 3, 5, you are going to write like this. So look in this question, what it is given. It is given F1 is min term 4, 5, 6, 7, 8. So this is 4, 5, 6, 7, 8. F3 is 1, 6, 15. So what is this F3? So I guess this will be F2. Okay, F2 is 1, 6, 15. So 1, 6, 15. Look here, 15. That means this is a Boolean expression having 4 variables. Okay, because with the help of 4 variables only you can get min term number 15. So the minimum is 4 variables. So and F is what? F is this output. So that is 1, 6, 8, 15. So they are asking what is F2. Means they might be asking what is F1. So what is F1? So there is some typos over here. So what is F1? So look over here. 1, 6, 15. This is coming from F2. So 1, 6, 15. This is coming from F2. So here you need 8. So 8 must be coming from this output of AND gate. So over here you can see 8 is present in F1, means F1. So that means what? Over here in F means, I think this should have been what, I did some mistake or what? This is F3, this is correct. They have written F2 over here. So this will be F3 and this is F2. Okay. So 8 must be common over here also. 8 must be common over here. So look in the options now. Where do you have 8? So 8 is present over here, and over here. But if you take 4, 6, 8, then what will happen? See, if you take 4, 6, 8, so 4, 6, 8. If you take option C, so even this is wrong, option D, completely typos are present. So if you take 4, 6, 8, then 4 is common over here, 6 is also common, 8 is common. So then 4, 6, 8 will pass through this AND gate, and then you will be getting terms of 4 over here. Okay, 4 you will get over here, but that is not the output. You don't contain 4, so option D is wrong. Now look option B. Once again there is 4 and 8. So if you have 4 over here, so this 4 is common in the F1 also. So again this will be what? This will be 4 comma 8. So 4 will be present over here. So option C is also wrong. Look at option B. Sorry. Option B is also wrong. 4, 8. Now look at option C. It is basically what? 6, 8. So if you take 6 comma 8, then 6 is present over here, 8 is also present. So the output will be what? There is something wrong or what? 6 is present over here also. So F1 is 4, 5, 6, 7. So even if we take 6, 8, so 6, 8 will be wrong because 6 will also come. Okay, so this is okay. 6 comma 8. Very good. Means I only made some mistake. Okay. So 6 comma 8. Look here very carefully. If 6 comma 8 is coming, it's okay because 6 is common over here and 6 is common over here, and even in the output we have 6. So it doesn't matter. Okay. So option C is correct. Okay. Option C is correct. Did we understand this question? Such kind of questions might be asked. Okay. Such kind of questions might be asked. So now this question, tell me very quickly. Last question for today. In the next session we are going to study about prime implicant, essential prime implicant, and then we are going to start combinational circuit. So combinational circuit means there is no such concept that might be asked in your this PSU kind of exam, because from combinational circuit usually the questions are very lengthy and time consuming. So I am hoping there will not be that much concepts. So again we will be getting simple conceptual questions from sequential circuit, so that will be very important. So combinational circuit we might be able to finish in just one class. With this question we will even cover the 4 variable KMap. So what is given? Consider the following Boolean function with 4 variables So these are basically min-term number given. The function is independent of one variable, two variable, three variable, or all variable. So this you can directly cancel out. Why? Because if it is dependent on all variable, I thought this is independent on all variable. So look, min-term numbers given are 1, 3, 4, 6, 9, 1, 3, 4, 6, 9, 11, 12, 14. 11, 12, 14. Okay. So these are your min-terms. So very quickly, write the SOP. So one of the groups you can make like this, another like this, another like this, and one more like this. Tell me, is this correct? Is this correct? This is not correct. This is not correct. Why? Because if I see any gray code, I had told you, in gray code usually there is a change of one bit, or basically it is a cyclic code. Okay, sorry, cyclic I am telling, reflective codes. Okay, reflective codes. So if I join this point with this point in a in a cylindrical manner, this 2 point means this two places, this two cells will be adjacent to this two cell. So this will be one group of 4 and another group of 4 will be this one. So now if you write the SOP expression for this one, here you can see x equal to 1 is common. So x, and in yz what is common? Z bar is common. So x z bar plus over in this group. So you can see out of wx what is common? Again x complement. Okay, x complement is common in this two. And over here what we have common? Z equal to 1. So this is the case. So this is what? This is basically x XOR with z. So here out of w, x, y, z, we have only x and z. So basically it is independent of two variables. Two quads possible, sir. Yes, very good. Okay. So this is independent of two variables. So option B is correct. So this question will be your homework. So quickly take a screenshot of this question. Screenshot. Taken? Okay, fine. Okay, then we will be stopping over here only. Okay. Surjit was waiting in the lobby. So Surjit, from when were you waiting? I didn't even knew. Okay. So this is one drawback. I am very sorry. I am very sorry. I couldn't see, means I was busy in making this lecture, so I couldn't see. I am very sorry.